Hey Earth Science Explorers, welcome back to another session of 3D questions from STEAMspirations. I'm Mr. Lara, and today our objective is to understand how sedimentary rocks are formed and to explore the natural processes that shape these rocks over many years. To learn more about today's topic, click the right corner of your screen to watch a video that provides an in-depth explanation of sedimentary rock formation. This will help you visualize the various stages involved in creating these rocks, from the initial breakdown of materials to their transformation into solid rock layers. Also, make sure to have your Level Up workbook ready to jot down your answers and reflections as we go through today's lesson. Before we jump into today's exploration, don't forget to hit that subscribe button and click the notification bell so you never miss an exciting discovery. Now let's get started. Sedimentary rock formation begins with weathering, where forces like wind, water, and temperature changes break down large rocks into smaller particles. These small fragments or sediments are then transported by natural forces, such as rivers, wind, or glaciers, in a process called erosion. As these moving sediments lose energy, they settle and accumulate in layers, which is known as deposition. With time, as more layers build up, the weight and pressure from the upper layers push down on the sediments below, compacting them tightly together. This process is referred to as compaction. Finally, minerals dissolved in water seep into the compacted layers, acting like a natural glue that binds these particles together. This last stage, known as cementation, completes the transformation of loose sediments into solid sedimentary rock. To recap, weathering, rocks are broken down into smaller pieces by natural forces. Erosion, the movement and transportation of these broken pieces by forces like rivers, wind, or glaciers. Deposition, the settling of sediments when the transporting forces lose energy, forming layers. Compaction, the squeezing and pressing of accumulated layers of sediments due to the weight above them. Cementation, the binding or gluing together of sediments by minerals and water, forming solid rock. Now that we reviewed the sedimentary rock formation process, it's time for an interactive challenge. Here's your task. Imagine you're a scientist studying different environments to understand how sedimentary rocks form. You have collected samples from various locations, each representing a different stage in the sedimentary rock formation process. Below are descriptions of each sample. Sample A, large jagged pieces of rock with sharp edges, recently broken off from a mountain. The surface shows signs of weathering with cracks and crumbling edges. Guiding question: what natural forces might cause these rocks to break down into smaller particles? Think about how different environmental factors such as temperature changes, water, and wind contribute to this process. Sample B, a mixture of fine sand, silt, and small pebbles, appearing smooth and rounded. These particles seem to have been carried by a river over a long distance. Guiding question: how do natural forces like water or wind transport these particles from one place to another? Consider how this movement might affect their appearance and shape. Sample C, distinct layers of fine particles settled at the bottom of a lake, each layer representing a different type of sediment deposited over time. Guiding question: what happens when sediments transported by natural forces lose their energy? Reflect on how particles settle and form layers over time. Sample D, compact and dense material made of tightly packed particles with very little space between them. The material feels solid and shows no sign of movement or shifting when pressed. Guiding question: what role does pressure play after sediments have been deposited? Think about how weight and compression contribute to this stage. Sample E, a solid rock with visible grains that appear to be glued together by a mineral substance. The rock is hard and durable, with no signs of separation between its particles. Guiding question: what could cause these compacted layers to solidify into cohesive rock? Consider how minerals and water might act as a binding agent. So here's your next challenge. A 3-step process is shown: deposition, compaction, cementation. Which of these are most likely formed by the process shown? A, glaciers. B, mountains. C, sand dunes. D, sedimentary rocks. Guiding question: think about what these processes, deposition, compaction, and cementation, lead to. What kind of natural formation results from these stages? Consider each option carefully and use the clues from our discussion to decide. Here's your additional challenge. Sediments are transported by various forces across the Earth. Which type of sediment transport is most likely to create the smallest, most rounded particles? A. Transport by rivers. B. Transport by glaciers. C. Transport by winds. D. Transport by ocean currents. Guiding question. Consider which type of transport involves continuous movement and abrasion, causing the sediments to break down into smaller, smoother particles over time. Think about which natural force would most effectively create tiny rounded grains. Now it's your turn. Use these guiding questions to help you analyze each sample and the processes involved in sedimentary rock formation. Think deeply about how each stage contributes to the creation of sedimentary rocks and record your answers in your Level Up workbooks. Let's summarize what we learned today. Today we explored the formation of sedimentary rocks through a series of natural processes. We started by learning about weathering, where rocks are broken down into smaller pieces by forces like wind, water, and temperature changes. These smaller pieces or sediments are then moved by natural forces such as rivers, wind, or glacier in a process known as erosion. We then discussed deposition, which occurs when these sediments settle and build up in layers after the transporting forces slow down. As more layers accumulate, the weight of the upper layers causes sediments below to be pressed tightly together in a process called compaction. Finally, we learned about cementation, where minerals dissolved in water seep into the compacted layers, binding the particles together to form solid sedimentary rocks. We then applied this knowledge to identify which processes create certain natural formations, such as sedimentary rocks, and thought about which types of transport methods result in the smallest, most rounded particles. These exercises helped us connect each stage of sedimentary rock formation and understand the roles that different natural forces play. Now it's time to put your knowledge to the test. Remember to record your answers in your Level Up workbook. Reflect on the processes of weathering, erosion, deposition, compaction, and cementation, and how they work together to form sedimentary rocks. Consider how different forces of nature move sediments and how these movements affect their final shape and size. Keep thinking critically, stay curious, and continue exploring the world around you. There is so much more to discover about our planet, and your observations and questions are the keys to understanding it all. Until next time, keep up the great work as Earth Science Explorers.